Hello students, today we are just going to discuss the chemical properties of haloalkane only. Chemical properties of haloalkane of haloalkane means that we are going to discuss the chemical reactions. Number one is nucleophilic reactions. Nucleophilic substitution reaction. Nucleophilic substitution reactions. Haloalkane are showing such kind of reactions. Nucleophilic reactions are actually are of two types. Number one is SN1 and number two is SN2. SN1 reaction, first I will tell you the points, then I will explain you each and every point. SN1 reaction will complete in two steps and SN2 complete in one step. This I will explain you by writing the example within 2 or 3 minutes. Number 2, SN1 is first order kinetics. First order kinetics and SN2 is second order kinetics. Second order kinetics. Number 3 is SN1 takes place in the presence of polar protic solvent. Polar protic solvent. And SN2 takes place in polar aprotic solvent. Aprotic solvent are those which do not give the proton. Later on I will discuss this also. And in SN1 the reactivity order is 3 degree carbocation is greater than 2 degree is greater than 1 degree, and in this one it will hidden step I will explain also. 1 degree is greater than 2 degree is greater than 3 degree. Now the fifth point is in SN1 reaction there is racemization and retention occur. Retention takes place. I am just going to explain also this one. And SN2 there is only conversion of inversion of configuration. Sorry for this one. Inversion of configuration. Inversion of configuration. I'm just going to explain you now this reaction. These are very important action. You must take care. First you go with the differences, then I'll come with the point and reaction. Now I'm just going to explain you the SN1 reaction. Suppose that this is an alkyl halide. I can take any. Suppose that I'll take CH3, CH3 and CH3. And here is an X, that is the haloalkane. If I'll take one nucleophile, my dear students, you also aware what is nucleophile, which can give the electron. If I'm just going to explain, this is SN1. This reaction will take place in the two step. You see there, it is breaking down and we are getting what? CH3. First it will only alkyl halide will broken down. CH3, C, CH3. I can take only RX also. Here I am taking tertiary carbocation. You are watching here, I am getting carbocation separate and this X separate. Now the rate of reaction depend on this step. This step is slow step. Always take care. Rate determining step is slow step. And in slow step, there is only alkyl halide. There is only alkyl halide on which the rate of reaction depends. So that's why it is called SN1, means of that unimolecular substitution reaction. Rate of reaction change in concentration per unit time will depend only upon the concentration of alkyl halide. That's why these are called SN1 reaction, unimolecular substitution reaction. Here now I'll get, this is slow step, this is carbocation. CH3, C, CH3 and CH3. Here is getting plus charge. Now in second step, this is the second step, this is first step. SN1 complete in the two step. Now any nucleophile will attack. Nucleophile means the species which are having electrons. It can be OH group, it may be NH2 group, it may be, if I'll take AgOH, then OH will be there. Nucleophile are electron donating species and nucleus loving species. Now nucleophile will attach with this carbocation and our reaction complete. CH3, C, CH3, C, and this nucleophile attach here and U. So this is SN1 reaction. You are watching on the blackboard. This is SN1 reaction where the rate of reaction will depend on only on alkyl halide. That's why these are called SN1. And first step is slow step. And slow step is always rate determining step. Slow step is always rate determining step. Rate of reaction can be measured out from slow step. Rate determining step. And rate is change in concentration per unit time. Now we will come to explain or to understand or to discuss with you guys what is SN2. SN2 reaction is what? In SN2 reaction, if suppose that now I'm just going to take only RX. R is what? Alkyl group, methyl, ethyl, propyl, butyl, and RX react with the nucleophile. This is a nucleophile, and R is, if I'll take this R means of that methyl group, here H, here again H, here again H, and nucleophile also attach in the one step like that, and U, and here is X. This is the intermediate step, and now the rate of reaction will depend upon both nucleophile as well as alkyl halide. That's why this is called SN2 reaction, unimolecular substitution, bimolecular substitution reaction, not unimolecular. Bimolecular means of that rate of reaction will depend upon the two things. Bimolecular reaction means of that alkyl halide and nucleophile. This is intermediate step. This will break down, and nucleophile actually come from back side. Here we cannot show the nucleophile. We can take here H, or any alkyl group may be attached. We can take H here, and we will show the nucleophile here in place of hydrogen. Because of that, this is backward reaction. I am just going to explain also you why inversion of conjugation takes place. Nucleophile will come this place. This will break down, and we will get C, H, H, H. I can replace the H with R, and this is what the nucleophile. Nucleophile may be OH, NH2, AgOH, RNH2, or anyone else. This is a simple explanation of SN1 and SN2. Now I'm just going to explain you the more step of SN1 and SN2 which help you definitely and cracking the question of any exam. Now I'm taking one example and explaining you how the what did you mean by the racemization and retention? Both SN1 and SN2 included here. Suppose that if I'll take C, this is H, this is H, this is H, and X is here, any alkyl halide. You're looking, guys, if the nucleophile will attach now, and nucleophile will attack and replace this alkyl, this is halide ion from the same direction, then you will get what? This is called retention. C, H, 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 and nucleophile coming on the side where we are replacing the X. This is called retention. And when means of that, from which side the X is replaced, on the same side nucleophile is coming. That is called retention, which I am making earlier. Next is that racemization, or first I would like to go with the inversion of conjugation. That inversion of conjugation is the, if I'll attack any nucleophile here, this will come the side opposite of the nucleophile, of the halide ion. This nucleophile will come this side. This is again H, this is again H, and here also H, X we will get as a side product. Now you are watching that nucleophile is going the side where opposite to the halide ion. Halide ion are this side, and nucleophile is coming on this side. So this is called inversion of configuration. This is called what? Inversion. And if we will understand, this is inversion, opposite side. Suppose that inversion is the character of SN2, why it takes place, and retention is the character of SN1. Suppose that this is A and this is B, the product which we will get after attacking the nucleophile on the alkyl halide. If I'll get A plus B both, that is known as racemization. And racemization is the character of SN1 also. As I earlier told before 2-3 minutes, racemization is why happens? Why happens racemization? Because of that, if I'll take this CH3 and CH3, CH3, due to the symmetric CH3, and this is the H, due to the planar, if I would like to explain you why racemization takes place, this is this H, this is the X, and in nucleophile not, this is halide. This will be replaced and we will get what? C, CH3, CH3 and CH3. So what? Both sides are open, free. This is the tertiary carbocation. I am just going to explain you. And now nucleophile, suppose that if I will take OH, that can attack from both sides, here and here also. Why it can takes place? Because of that carbocation is acryl. Carbocation is acryl. And acryl means, here I told you, the carbocation is acryl. Acryl means there is a planar, it can be attacked. Acryl means symmetry is there. Means that carbocation can be attacked by nucleophile from both sides. Like again CH, this is CH3. This is a very important point. Make yourself difference with other student. You can put this question, why the racemization takes place. Now your answer is ready. Because of that, OH can attack from this side as well as from this side. If he will say that why this happens, you will say that due to the carbocation is equal symmetry. You understand that whenever the symmetry is there, we can come from both sides, and it can be attacked from both sides, and that is what is called racemization. My dear student, please listen it carefully and do it carefully and score your better marks. Definitely it will help you. This is OH. This side, this is OH from this side. This is, my dear student, racemization. And I told you why the racemization takes place. Because of that, the carbocation formed, that is acryl. There is a symmetry. Now you are watching, OH can attack from both sides. OH is what? Nucleophile. This is what? Carbocation. And acryl and chiral, you must attended my classes. I'll just also explain the chiral and acryl in the local language also, approachable to you. Chiral means whenever carbon atom is attached for different group, and acryl means whenever two same and there is symmetry. Chiral means there is no symmetry. Now the next point is that if he will ask you simply a conclusion why the racemization takes place, in one word you will say answer, this is due to the plane of symmetry. Plane of symmetry. In the earlier next coming classes, I will also explain you what is meso compound, that is beyond the limit of CBSE, and it will come in other exams also. Then the next point is that to solve the questions, this racemization clear, retention clear. Now one more question is that reactivity order. Reactivity order, which I told you that in SN1, the reactivity order is 3 to 1. Means of that tertiary carbocation is highly stable and more reactive than 2 degree. Means of that secondary carbocation is more stable than primary carbocation, and it is also stable and greater than methyl. This is SN1 and this is SN2. Means of that 1 degree is greater than 2 degree is greater than 3 degree. Why it happens so? Because of that, the tertiary carbocation stability will increases. The stability of carbocation and tertiary carbocation is more stable. That's why SN1, and number of reactions are there which I will form in front of you the tertiary carbocation. In alcohol phenol ether, if you follow the CBSE 33 question where we make the tertiary carbocation by the hydrogen shift, I'll explain in the coming classes. This is what the SN1 and SN2, definitely one question will come from this part. And last point of the SN1 and SN2 is that why we will take the polar solvent. Last point. In SN, the point is that in SN1, we are referring the polar protic solvent. If you are not getting understand, you can put your queries. What do you mean by the polar protic solvent? I definitely give you answer, and I am available for you guys. Polar protic solvent help in SN1 due to its ability of solvation. Due to its ability of solvation. You please put this answer and get secure marks. One more important and interesting things in SN1 and SN2. Suppose that we are trying to cross one question. In SN1, I told you the reactivity depends upon the stability of carbocation, and stability definitely will come from 3 degree is greater than 2 degree is greater than 1 degree. But what is the reason of stability? In SN2. In SN2, I told you 1 degree is greater than 2 degree is greater than 3 degree. Why this happens? This happens due to the steric hindrance, my dear student. Steric hindrance. If you are not catching the word steric hindrance, please contact me, and I am just going to explain one question of SN1 and SN2. Actually, what happens? We understand all the concept, but when we are putting the question and you find difficulty, definitely one example I am just going to share with you. That is, suppose that he will give you this example, C6H5 thrice and CBr, then C6H5 CH3Br, and one more example, this is C6H5 C6H5Br and CH3Br. First of all, you must try to open this one. If I open this one, I'll get this, the carbon, and here is C6H5 and C6H5, and it is Br. Now this is 3 degree aryl halide. Now the second I am just going to open. This will comes to you C6H5 CH3 and H and Br. Now open the third one, which I made it a little bit wrong. I am just going to clear this one. This is the task which I would like to share with you. This is the, yes, it was right. We can go with the same example. We can put here C6H5, no problem. Now open this. What is this? C6H5, and this is again C6H5. This is Br and this is H, and this is simple, C triple H and 1 Br. It is clear, my dear student. This is 3 degree, but this is 2 degree, and this is 2 degree. Now the problem is that whenever 2 degree are 2 same, which you will take first in the SN1 and which you will take first in SN2. Just 1 minute for this lecture, please be with me, because here only the problem is that C6H5 and C6H5, this is H and this is Br. This is 2 degree. Now again C6H5 CH3 Br and H. This is again 2 degree. So it is a problem. Whenever we are going to with SN1, you definitely take these 2 priority. This means that A will get preference over B in SN1 in the 2 degrees. But if I'll take SN2, in SN2 the steric hindrance present. If we will say that in SN1 why we prefer the A, you can say that due to resonance, and SN2 I am preferring B is greater than E. Why? Due to the steric hindrance. This is the question also. And after that, if you are getting any problem, then no problem. Please be in touch with me. I am here for you. This is the CH3Br. This is 1 degree. In SN1, we will go with the 3 degree is greater than 2 degree and greater than 1 degree. And SN2, that is the 1 degree is greater than 2 degree is greater than 3 degree. Whenever the 2 bigger groups are coming, that is get preference in SN1 due to resonance, and SN2 due to the steric hindrance, it will be stopped. This is what holds over SN1 and SN2. If any other query, you can put. One more thing I would like to explain you in the SN2 for the next classes. Thank you guys. Goodbye. I hope so that you understand.